Hi everyone. Today I'm going to explain how to design a recursive function to determine whether a given binary tree is a valid binary tree search or BST. To validate a BST, comparing a node only with its immediate children is not enough. All nodes in the left subtree must be strictly less than the current node, and all the nodes in the right subtree must be strictly greater. Therefore, the key approach is to propagate a validate range of values, minimum and maximum boundaries as we traverse down the tree. Algorithm and base case. Our function will accept three parameters: the current node, a minimum allowed value, and a maximum allowed value. For the initial call, we pass the root node along with negative infinity as the minimum boundary and positive infinity as the maximum boundary. Moving on the base case. If the current node is null, it means we have reached the end of the valid branch without any violations, so we return true. If the node exists, we validate its value against our boundaries. If the node value is less or equal to the minimum or greater than the or equal to the maximum, the tree violates the BST property, and we immediately return false. Recursive case. If the current node values lies safely within the boundaries, we proceed to the recursive case. Number one, for the left child, we call the function keeping the current minimum boundary but updating the maximum boundary to the current node's value. This ensures no node on the left exceeds the parent's value. Second, for the right child, we keep the current maximum boundary but update the minimum boundary to the current node value. Finally, we return the result of a logical AND operation between both recursive calls. The tree is a valid BST only if both the left and the right subtrees satisfy the BST criteria within their respective bounds. Conclusion: this approach guarantees a linear time and complexity of the M, visiting each node exactly once to achieve an efficient and correct solution. Thank you for your time.